Module 4, Lesson 11's objective is to demonstrate possible whole number side lengths of rectangles with areas of 24, 36, 48, or 72 square units using the associative property. Item 1. The rectangles below have the same area. Move the parentheses to find the missing side lengths, then solve. Item A. As you can see, one side of this rectangle is 4 centimeters and the other is 9 centimeters. In order to determine the area, you multiply the 4 by the 9. And 4 times 9 is the same thing as saying 4 groups of 9. If you don't know what 4 groups of 9 makes, then you could draw 4 groups. You could put 9 in each group and add them together. 9 and 9 is 18. 9 and 9 is 18. So 18 plus 18, 8 and 8 is 16. 1 and 1 is 2, and 1 more is 3. So 4 groups of 9 is 36. Now let's look at item B. This time, one side is 1 centimeter and the other is 36 centimeters. Again, in order to determine the area, you multiply one side by the other. 1 times 36. That's the same thing as saying one group of 36, which is 36. Now let's look at item C, which is right below item B. This time, they only give us one side length, and that is 2 centimeters. The other side length is missing, but what you do see is a multiplication problem for the area. Here you see 4 times 9, which is the same thing as 2 times 2 times 9. Remember that 2 times 2 is the same as 4. Now, if we use the associative property of multiplication and move the parentheses so that instead of being around the 2 times 2, they're around the 2 times 9, then what we have is 2 times 2 times 9. 2 times 9 is the same thing as 2 groups of 9, which is 18. Now let's take a look at this multiplication problem. Look, there's a 2, just like this one right there. So this 18 must go here. And 2 times 18 is the same thing as 2 groups of 18, which is 18 plus 18. Remember, we did that over on the other problem, right over here. So 8 plus 8 is 16. There are 6 ones in 16 and 1 10 in 16. 1 10 plus 1 10 is 2 10s, plus another 10 is 3 10s. So the area of item C is also 36. Let's look at item D. Oh my goodness, they did not put any of the side lengths, but they did help us by beginning the equation for the area. Here you see 4 times 9 again. This time, though, they decomposed the 9. So they kept the 4, and then they multiplied 3 times 3 to get the 9. So 4 times 9 is the same as 4 times 3 times 3. Using the associative property, we're just going to move the parentheses this time so that they're around the 4 and the 3. 4 times 3 is 4 groups of 3. And that we can do by skip counting. 3, 6, 9, 12. That's 4 groups of 3. So that's 12 times this 3, which goes right there. Now we know the side lengths. 12, of course, is larger than 3, so I'll put 12 on this side and 3 on this side. Now 12 times 3. We need to figure out what the answer to 12 times 3 is. For me, the easiest way to figure out what 12 times 3 is to write it out horizontally like this. Decompose the 12 to be a 10 and a 2. So 12 times 3 is the same thing as 10 times 3 plus 2 times 3, which is the same thing as 10 times 3 is 30, and 2 times 3 is 6. So that equals 30 plus 6 is 36. And that's the answer to item D. Now let's look at item E. Again, they used no side lengths for clues. They gave us the equation for the area, 12 times 3. 12 times 3 is the same thing as 6 times 2 times 3. If we use the associative property of multiplication, we can move the parentheses to be around the 2 times 3. Now, that makes the next one 6 times 2 times 3, which is 2 groups of 3, and that's 6. 2 groups of 3 is 3 plus 3. That's 6. Now, look at there. Now we know the length of each side is 6 centimeters. So what is 6 groups of 6? 6 groups of 6 is the same thing as counting by 6 times. Let's do that here with skip counting. 6, and 6 more is 12, and 6 more is 18, 6 more is 24, and 6 more is 30, and 6 more is 36. That's 1, 2, 3, 4, 5, 6 groups of 6. That makes 36. Problem 2. Does problem 1 show all the possible whole number side lengths for a rectangle with an area of 36 square centimeters? How do you know? Well, in order to figure out if all of the possible whole number side lengths have been utilized, I'm going to go ahead and make a chart for the number 36. I'm going to think about all of the factors I know that when multiplied together get the product of 36. Well, I know that 1 times 36 is 36. Now, I'm going to go in order to make sure I don't skip anything. I know that 2 times 18 is 36. I know that 3 times 12 is 36. I know that 4 times 9 is 36. 5 doesn't go into 36 because all multiples of 5 end with a 5 or a 0. 6 times 6 is 36. 7, no, 7 doesn't go into 36. 8, no, 8 doesn't go in 36. 9, oh look, I already see 9 with a 4 up there. 10, no, not 10, because all multiples of 10 end with a 0. 11, no, because 11 times 3 is 33, so that wouldn't work. And then we already have 12. So those are my possible combinations. Now, I just need to look at the top. Do we have a 1 by 36? Yes, we do. That's item B. So I'll put a B here. Do we have a 2 by 18? Yes, we do. That's item C. So I'll put a C there. Do we have a 3 by 12? Yes, we do. That's item D. So I'll put a D there. Do we have a 4 by 9? Yes, we do. That's item A. So I'll put an A there. And do we have a 6 by 6? Yes, we do. So I'll put an E there. So does problem 1 show all the possible whole number side lengths for a rectangle with an area of 36 square centimeters? Yes. Problem 1 shows all the possible whole number side lengths for an area of 36 square, SQ stands for square, centimeters is cm. I know this because I made a chart of factors. Okay, that's it for this side.